18 years, primarily Oracle database. I switched over about 2.5, almost 3 years ago to MongoDB with Object Record by Rackspace. I've enjoyed it. There are times that I've wanted to pull my hair out literally. Other times it's like, oh, okay, it's a great thing. I've got a guy back there, David Murphy, that did some initial training and stuff like that and kept me on my toes. So all that's a good thing. But basically, a lot of different industries, specialties. I've always loved like storage, hardware infrastructure, and worked in gaming, early online auto auctions with Java applications that were so slow you wanted to pull your hair out literally, not just figuratively. So, but that was all fine. And then also Hibernate, working with Hibernate. I don't know if any of you guys still use Hibernate as a layer, but man, that one truly killed me back in the day. So, but go ahead and get started here. This is going to be about sharding. It's not what it says on the thing about IoT. I'll throw in some IoT stuff regarding cloud in there as kind of go along. So here's what we're going to talk about this other way though, right? Sharding, why do it, when to shard, when not to do it, the process overall, and then selecting shard keys, the difficulties that you have there, and problems and the fun, tips, examples of managing sharding, scaling, and then other ideas and storage engine considerations. So we've heard a lot of talk throughout the last 2 days and today about the engines, the different engines. So a lot of this will be old news to you guys now. You'll be totally prepped and had at it, new hat. So basically what is it? To me, sharding equals nothing more than horizontal scaling, the equivalent of partitioning in like MySQL, Oracle RAC, or any of these other type of technologies. So again, you have two ways to scale. You can scale up vertically, old school big iron, lots of massive expense, that type of thing, or commodity hardware shard out. Basically, you can get a lot more bang for the buck, and you kind of just keep going along the way. So that's pretty much what you have to say there. What you win and what you get out of the horizontal sharding, primarily, you get many different sources and types. You get redundancy, you get your fault tolerance. So if you lose a node, your data is already existing on your other nodes. You can just fail over. You can add additional resources on the fly. Historically at Object Rocket, we use 3 member shards, replica sets for the shards. So that gives you your forum that you need. Flexible, scalable, HADR. So, again, I mentioned hardware, big iron. I used to have a thing up there that had big blue on there, but kind of taking that out of the thing, kind of goes around that. We're totally different today. We can talk about the old school style, where you had like the Oracle RAC, because that's what my background is. And you see all the different components and all the different pieces that you have to have. So you compare that to today, right, where you get just horizontally, you go smaller and smaller. Or you can even put it containerization, virtual host, which is what we utilize a lot. And more people are utilizing that today. It's primarily what the cloud is and what you're doing with it. So massive CPUs, you don't really want to do, but you don't want to go up, you want to go out. So horizontally, you want to go more. And there's my little monetary symbol to talk about that. So why do we want to do this, right? Why in the world do you want to do it? Well, very simple. Scalability, performance, high availability, reliability. Everything has to be there. You have to get started. You have to get with it. You have to have the performance to get started, right? Even at the lower levels, big data. The current RDBMSs will not work for you the way that they used to. So we talked about that. So this is kind of an interesting quote. What do you do when Twitter or Facebook or whatever breaks? It's kind of like, what do you do when you don't have your iPhone? So this was a quote. Someone ran a campaign. What do they do, right? What happens when Twitter goes down? And then all this thing is like, go into the streets and cause riots. So why do it? Why big data requirements? You have to have the high availability, right? A few minutes. You just keep going. And that's pretty much what that is. So next, the Internet of everything, the Internet of all, the Internet of things. What exactly do you want to call it? It doesn't matter because it's all going to be there. And we're still, again, just at the very tip of the growth that we can have coming up. I mean, it's just totally massive. You'll see in the next slide, like the number of dollars. It's not just the user data, it's the mobile data. It's even more explosive growth that you can talk about. Everything. Everything is monetized. That's what the companies care about. That's what keeps us in jobs and keeps us paid and keeps us interested in going forward. Granted, some of these things along the way tickle our brains and frustrate us, but it also keeps things fun for us. So why do you make the change? Why go NoSQL, right? There you go. Faster, more flexible development. So this is from a poll. Why do most companies want to utilize NoSQL as opposed to other data texts? Faster, more flexible developers. As a DBA, this was one of the biggest things. This actually was one of the reasons why I made the switch as well from a traditional RDBMS DBA, because the developers get so tired of schemas, your structured schemas. You wanting them to do, okay, you do this. This is what your structure is. We need all this data. This is required. This is a required field, etc. But the developers say, well, no, I don't want to do that. I want to do schemaless. I don't want to think about this. I just want to shove the data in there, and I want to deal with it later. So the 24% of the managers said they wanted faster, flexible, agile. So this is what we do. 21% said we want cheaper, we want faster, and we want better deployment. And then faster writes, faster reads, and then the cool tools, right? There are a lot more developers than there are DBAs. So we won this one. And then, of course, you just have the overall variety of the NoSQL technologies. MongoDB is just one. You've got Cassandra, you've got Neo4j, you've got all the ones that I talked about ever. But the thing to remember is it never really is truly schemaless. Now, I'm going to say this in almost every talk that I ever give in my whole entire life, because as the DBA that supports your application, I'm the one that's going to have to help you out when you don't think about these things ahead of time. So even though it says schemaless, you always need to think about schema, because if you don't, you're not thinking about your app design, you're not thinking about your long-term flow, and you're going to run into a problem later on that you could cause to fail, like an actual failure. So you'll just store data, you may never even use it, and using NoSQL will not win anything at all for you. So it'll just become a data wasteland, right? On this particular slide, garbage in equals garbage out, right? That's really what you're looking at. So here's a comparison that compares RDB's slide that compares relational databases and your NoSQLs. Records versus documents, tables versus collections, buckets, other tables, rows versus fields, set data types, flexible, rigid schema structure versus unstructured, semi-structured, you know, all the different varieties. Primary keys versus document keys, RIDs. Some of the newer ones have some semblance of an idea of a primary key now. And then normalize versus denormalize, although we heard earlier that some people are still denormalizing their current structures and placing everything in one system, one place, so that they can pull the data all at once. And that happens. I think Aboy mentioned that, and also Kat from Washington Post mentioned that. But Aboy uses it on a much more limited scope than that. So in the end, duplicated data is okay. Disk storage is cheap. Memory is expensive. The bigger your data size, your document size is, the more you'll pull into memory. And if you're not pulling that much into memory, you're only talking about a couple million records or something like that. That won't matter, but if you're pulling billions and billions of records in, your document size will matter. Your field size will matter, as Jason talked about earlier today. So, referential integrity, duplicated data is okay. You know, you joins in RDBMS now. In the NoSQL world, you're starting to get joins via indexes, being able to use more than one index at once, having optimizer engines that work the way they should. Going back to like Oracle 8i, optimizer engines never worked the way they were supposed to. Then they fixed them for a while until they got to 10.1. Oracle optimizer engines never worked the way they were supposed to until they got to 10.205. And then from then on, they've been pretty good. And I haven't worked that much with Oracle 12 because I've been playing in NoSQL land. So, going back to sharding. When do you need to shard? Like, what is it that you really want to do? When you need better performance. So, you have a box that has this many resources. Your resources are being totally consumed by what you're doing on this one server, this one replica set, or this one shard. So you shard, you horizontally scale, you add additional components, right? Because you're going to add the MongoS, and you're going to add the additional MongoDs that you need, and you're going to add the config servers, which hold your metadata, the equivalent of like an Oracle data dictionary or someone. When you need additional write scopes, you add additional shards. So in the old Mongo stack, you would see DB lock percentage, and you would know that you needed to, hey, maybe think about adding additional shards so that you would get additional write scopes. Now with MongoDB 3.0 and above, and with WiredTiger, you get additional write capability. However, there's still the point where you have to size your shards correctly based on your document size, how much data you're pulling back, and the number of writes that you're going to be doing. We've recently gone through an exercise where we were going to go larger shard sizes, and then because of particular workloads, we had to scale that back down to add back in more write scopes. So it's always going to be about your workload. What are you doing? What is your application doing? The size of your queries, the size of the data you pull back, it impacts not only the number of shards, but it impacts the memory and the CPU that you're utilizing, the RAM and everything else. So the other thing is, remember that when you add shards, you're going to have to balance the chunks across the shards. And depending on if you have your balancer window set to run all the time, that is it's a write activity, as Jason mentioned earlier. Anytime you have the write activities, it's going to impact your performance. So you want the shard before. Say you wait till you get to 95% full on your first shard, and then you have the shard, and then the balancer kicks in, and it's during your heaviest write time. What do you think is going to happen? You're going to have some write contention there as your balancer moves the chunks and distributes it evenly across your new shards and or one shard. Some people want to know whether you add one shard. If you're growing very rapidly and you know that, you may want to add more than one shard at a time. Our largest customers, including Tender, Outweight, some of these others, actually use more than one shard, add more than one shard at a time. They add quite a few at one time when they know they're going to need them. That way they're going ahead, they're taking the balancing hit, and they're spreading it out a long time. But they're also adding in a lot more write scopes. They also take a significant period of time to balance out. This happens with a lot of the multi-terabyte databases that we have as well. It can take up to days to balance out full database with a significant number of charts. So again, different use cases. If you're small, some of these things may not come into play. But as you grow and you scale with the Internet of Things and with more and more and more data, then that's going to keep going. And this takes you back to the other presentation, right? The best tool for the job, your polyglot persistence. So I know I'm talking fast, and it's kind of funny because I'm actually from East Texas. I should talk extremely slow, but I don't. So anyway, that's a little side joke. The polyglot persistence, I don't have this in the other presentation, but it tells you some of the use cases that you have for polyglot persistence and for certain types. You see there recommendations, your graph, your key value, your product catalog, MongoDB, your analytics. Yeah, that's debatable whether it's Cassandra or not, but this particular graph says that you can do analytics a lot in Mongo. Matter of fact, a lot of times people would do the analytics, the aggregations on their secondaries. But what you need to be aware of, if you have secondary reads set to preferred, and then you're also doing aggregations there, you can run into some problems. We had one particular large client that got 26.7 hours behind because they were doing aggregations on their secondary, and the oplog could not keep up and apply on that particular member. So 26 point something. So what do we have to do? Kill it, blow it away, and rebuild it with initial resync. Reporting, user activity log, that's a good use for that. So you just kind of keep going and take a look at that. So then we go back again to why MongoDB. Well, first of all, there's sentiment. And these numbers have changed because apparently, according to the conference yesterday, Mongo is significantly more important. But at any given time, if you'll look at the database engines report, it'll have MongoDB as number 4, which is, generally speaking, the highest of the NoSQL variants. And some of those will play. But I think like Cassandra and some of the others are actually moving up now since I made this particular graph. So still the fastest growing, still the most widely mentioned, and more importantly, it has the most widespread community support, which is important in terms of your drivers, right? Because you don't want to use things where you don't have driver support. Once a driver, if you're using, take the time to profile, you need to take the time to profile at level 2. You need to talk to your developers if you're not that person, and find out how they use it now, what it is they're actually intending, because they may not actually know Mongo or JavaScript or etc. They may not know the patterns. They just have in their mind what they think they're doing, and it's totally different than what they expect to do once it gets within Mongo. Then you need to also talk to them about what they plan for it to possibly do in the future, because things change. and they have in their mind, oh yeah, I know I want to add this feature in the future, but I'm not going to mess with that right now. Well, you need to probe them. It's your job when you're designing all this to probe them and figure it out and ask that, because that will matter in your query patterns going forward. So, easily divisible. Jason talked about this earlier. You want balanced chunks. You want increased cardinality in your shard key, in the field that you choose for your shard key, so that you don't end up with jumbo chunks. Jumbo chunks hurt you in multiple ways, right? The primary way you can look at it is this. If you have a shard that has a bunch of jumbo chunks because you picked a shard key that was not easily divisible or didn't have a high cardinality, then you're going to have one shard that storage grows exponentially because it's going to have all these jumbo chunks on it. And then you're going to have other shards that are smaller. So then you're going to have disk imbalance. And basically you'll have a hot shard. Every time you put data there, it'll be a hot shard. Every time you query data, it'll be a hot shard. So it will be a performance problem every time. There are different applications. Specifically, this comes into play with user, social media type applications. Right? If you have certain people that are hit on a more regular basis than others, then you're going to run into this problem. Like a popular picture. If the most popular photograph is all of its chunks and all of its data is on one particular area, then you may have query performance problems there. All right? So again, easily divisible. You want balance. You want increased cardinality. You want to improve the performance any way that you possibly can. Occasionally, you may have two fields that you know will always be queried and that you will require that to enable to gain the increased cardinality and to limit your return set. Because the smaller amount of data you bring back, the faster that it's going to come back, the faster your query will return, and the better your performance. So, Arley shard often. So, the other thing to remember about that, as we're going forward, is ask the additional questions, right? They are super important. And one other thing to remember, there is never going to be the perfect shard key, never. You're always going to have a trade-off. Something's going to happen that will make this particular field inopportune for some query patterns that you have, whether it's for your reporting or aggregations or certain queries. You always are going to have a trade-off. That's why it's super important to ask in the beginning, are you going to be more write-heavy, or are you going to be more read-heavy? Are you going to be 50-50? What's your workload? That question right there will really, really, really have an impact on what's going on. So, ask the questions. Ask now, brown cow. Okay. I bet none of you get that reference, right?
So this will show a little bit of ignorance, but you can transition your schema and have certain techniques for that, but you can't transition a shard key.
Right. Once a shard key has been determined, it cannot be changed.
But can you go to a different version? Can't you keep shard key 1 and then version in a new
Not
one?
within the same collection. You can create a new collection and you can create a new shard key.
And migrate to the new collection.
Right. Yes. And then migrate your data to the new collection. Now, you can do that. But the thing is, most people don't have the ability to migrate all of that data. Once you get to a certain size, you don't have the ability to migrate that data all at once. Again, unless you hack your config server. And most people that are DBA minded from the old school want to stay away from hacking their DBA minds to their config servers, right?
Well,
Think of it as a primary key in a relational database, right? It's much harder to change than that.
well, and even to the point of what she was talking about, you still have to be able to fit every chunk onto a single node. Because think of it in the old school way where you would rename a table so that you could move to a different version of your application and change that. You can do some stuff which is trickier and you have to know what you're doing or you'll mess your system up very badly at your end. But to do that, you still have to unchart everything to have on one location, because otherwise you can't figure out how to map the data.
Right.
Because it would get confused if you had two shard keys. How would you figure out where a single piece of data would live?
Right. Because think again, that your config servers are your metadata, right? All of your queries use the metadata from the config server to know which shards to go out to find a particular piece of data, right? So, rows, equivalent of rows or fields, like 0 through 50 will be on shard 1, 51 through 100 will be on shard 2, whatever, and the mapping for that is in your config server. And so in order to remap that, you have to put it all back in together so that so you basically have to unshard it. And the only way to do that is to export, dump and restore. All right. So again, I've already covered most of these. Ask the additional questions. All the work up front will matter significantly. Some people say, okay, we do a lot of writes, but we only care about the read activity. For example, a travel application. They make their money when they do the reads, not when they do the writes. So that gives you a little bit of a throw, a little bit of a curveball there. You need to make sure that you're leading them to make their money the right way. So, expected growth patterns, again, how fast you're going to grow, how much you're expected to grow per week, per month, per year, because that will also determine how soon you want to shard. Busy times of year, Christmas, Thanksgiving, Black Friday, January 31st, inventory time, batch reports time, any end of the quarter time. All these type of things come into play when you're picking your shard key. And then you know that you clean out your data twice a year in August and in December. All these things come into play. So the other thing, if you already have pain points in your current system, whether it's a MySQL, NoSQL, Oracle, whatever, think about those pain points before you keep going. So find out all those answers before you go. So then, how do you shard? Basically, it's a pretty simple thing. Like I said, you set your profile to 2, which is on. You get during a representative time period, because it's important that you get all of your query patterns that you expect. So if you have queries that run only at night, because you're going to have campaigns, message campaigns that only run at night, then make sure that you are querying at night. Patterns and predicates, aggregations, your types of queries per the namespace. You look at all these different things from your profile data. You check for nulls, because obviously, if your shard key, it can't be null, similar to a primary key in a relational database. The compound keys, you check your cardinality. You can check that, actually, it's better to check a lot of these things on your secondaries as opposed to on your primary, because you don't want to hurt your performance while you are actually running this. And then no perfect shard key. So, how to shard? Yep. Make sure you get the size of your collections as well. That comes into play. But you perform the profiling query pattern analysis. You select the best option. You create the required shard key index, which we'll give an example in a minute. You disable your balancer, because obviously you don't want things flying around while you're doing this. Then you enable sharding at the database level, so that's on a per database. Then you shard the collection, run the command, and you add the shards. Then you re-enable the balancer, because you want things to start flying at that particular time. So this is the basic process. You want to take your time, right? Here's an example of some old queries to run against your secondaries. Just some aggregation queries. So there you get a good cardinality. You see a pretty high number there for that particular export ID field. Here's another one. Again, just some real basic examples that you're looking at. And one more example. You're going to check for nulls to be distinct. You're going to look at sample values. A lot of people just say, okay, I'm going to run these queries. I don't really care what the data is. No. Stop and look at the data. Because while you're doing this, you want to look at your field size. You want to look at your document size. You want to see how big everything is, and you want to take that into it. So, and also, you want to look at different places within your collection. Don't just look at the front, because they could have been putting test data in that doesn't have all the information on the fields. Don't just look at the back, because the pattern could have changed significantly. You need to look everywhere. There's another one for you. And all these will be posted, so you don't have to worry about grabbing them or whatever. The limit 5 is just going to get only 5, because you don't need it back. There's an example count. So, and then here we get to the actual commands that you're going to run. So, shard key collection, create your index. Use your database, ensure your index, tell you what time. Background equals true. You don't have to do that anymore. Well, older versions, you wanted to do this first on your secondaries, and first secondary, then on your secondary, and then do a step down, make your primary, and now secondary, and do it then. But you don't have to do that anymore as of 2.6. You enable sharding at the database level, and then you run the shard command. So So pretty simple there, right? But make sure you do it all in order. Then, if you're doing it for a larger one, here's some things. Use JavaScript to create JavaScript. Do everything in a screen. So anytime you're doing work that cannot be interrupted, such as creating a shard key, run everything in the screen or tmux. Make sure that everybody knows not to go in there and kill it. You know, depending on if you want to run it as root or whatever your practice is, and then create as admin to the DB and run your commands. So pretty simple. Here's your other thing. So also remember to be proactive. Can't say that enough. Do it before you actually need to do it. So, and that's where you can get to the pre-initial chunk. If you know you're going to have a lot of chunks and from the very beginning, go ahead and do pre-initial chunk. And Jason talked about that earlier. Here's an example of using JavaScript to create JavaScript. And then here's an example of actually running it to pre-create the chunks that we talked about a minute ago. Double initial chunks 2,000. That's a decent amount, depending on how you're going. So, confirm that, and then get your balancer going. I think I changed the majority of these values significantly enough. So here's 3 different, so now we're talking about use cases, right? If you have large number of small size shards, you're going to have a lot of writes, a lot more writes. So you want smaller shards and need additional write scopes. Second, medium. You need the write scopes, you need users spread out so far, because you also have the read level going in. And then a smaller number of large size shards, right? You're going to have a higher number of connections or a higher number of queries. You're going to have more reads. You don't want to scatter gather across as many shards if you know that you're primarily going to be reading. So, but again, a good way to shard when you don't know what the application is doing is to shard on your IoT hash, but you should always know what your application is doing. So, here's a comparison of all those different things that I just kind of went through, giving some more examples that you have in play for the different ones, right? Approximate connection number and the information that goes about it. Now, bad shard keys. Some applications are inherently more popular than others. Facebook, Twitter, Instagram, and then Snapchat is more than Vine, Pinterest, etc., specifically around certain target groups. So if you are sharding and your key is going to be based on which social media application you're using, that is a bad idea, because you will be hotspotting when you're querying and when you're writing to the database. So, and this is what happens when you do that, right? You cry like a little baby. So again, disk imbalance, I talked about that, jumbo chunks, slow queries, slow performance, slow apps, unhappy customers, not money in your pocket. So, what do? We talked about this a minute ago when you asked the question. The primary way to do that is to dump and restore and to drain it all back into one single shard, like David mentioned a few seconds ago. All right? So dump and restore. Here's how you fix it. Dump the collection, drop the collection, recreate the collection, reshard the collection using the correct key, restore the collection from the dump that you restored. And if it's a huge collection, you just take an hour to do that. Okay, and then this is a way that you can estimate how long it's going to take to move the chunk, which is how you drain a shard. So you can use the remove shard command to allow the balancer to drain a shard, or you can write manual scripts to do that yourself. So move chunk command, you stop your balancer, you run that twice. You should get an error the second time, or a message in between. If you get an error the first time, you know that the shard is not actually empty. So, all right, so here's some script examples, some source examples, blah, blah, blah. Again, you can read through that. These are the commands, bad key, basic, etc. And now we're going to talk about the larger replica set versus sharding. Some people still, again, want to use a larger replica set, and this is why. Right? If they have lots of reads, you don't want scatter gathers. You have lots of data, but not a lot of activity. You need more normal resources and application. This is a religious war. Do not engage. Don't ever get into a debate with someone that thinks they know everything, because they know everything. So sharding, expertise for sharding. You have to have the ability to actually shard. You have to know what you're doing. These are some of the examples that you would utilize when you use this particular case. And then we're going to talk a little bit about storage engine considerations. That storage engine people have talked about a lot, but workloads come into play, your document sizes come into play, your type of activities come into play. With updates, a lot of small updates. I'm sure you may have heard it danced around specifically the last 2 days, but you do not want to use WireTiger if you have a lot of updates on smaller documents. That's not the best. Okay? You want to use mple for that. Continue to use mple for that. WireTiger is great when you have a lot of writes, a lot of new writes. So mple, and then Mongo Rocks, MongoDB. Those, I didn't really talk about that one in this particular one. So collection sizes, again, think now, here, in the future. Think about your hardware. And then here's just a quick, dirty WireTiger versus mple thing here. So heavy read loads. The other thing that I didn't really talk about is fragmentation. Fragmentation in earlier versions, like 2.4 and 2.6, you would have to defragment by blowing away a node and reinitial syncing it to clear up the disk space. You can also free up the disk space by dropping a database. Dropping a collection will not free up your disk space. So that just kind of pretty much goes through there. And WireTiger as an opposed opposition keeps you there. So I think that I actually ran through that one pretty quickly. Yep. Yeah.